Can we see? Wonderful. Okay, I am your new maths teacher. My name is Stephen. I will be teaching you maths now. Welcome to my class. Right, the product rule. I'm very similar to the physics teacher. He's my twin. Okay. Now, product rule. So, okay. Some things you should remember from semester 1. If y equals sine x, then what's dy dx? Cos x, yeah. Oops. Oh no, you can get it later, Khalifa, don't worry. You can just write this down. Yeah. Now, if y equals, let's say, x squared, then dy dx? 2x. If y equals x squared sine x,
Wow.
dy dx is not 2x cos x. Okay? Maybe it should be, but it's not. Maybe you knew that. Did you know that?
I forgot.
Yeah. Yeah. I can explain why it's not. Can I scroll down? Yeah. Scroll down? Yeah. You don't have a notebook, Ben?
No.
I gave me mine.
This is your book.
No, I didn't get mine.
This is the same book that you had with Joan. So where's the book you were using with Joan?
I thought you were going to give us another semester two.
Yeah, so...
Chemistry, we are done with the book.
Oh yeah, but you were only halfway through the maths book. So where is your one? It's okay, but you still have it. Yeah, fine. So you just need to bring that to class then. Okay, can I scroll down? Yeah. So let me explain why this doesn't work, okay? If y equals x squared, then dy dx should equal 2x. Yeah. If y equals x squared, that's equal to xx. This one's derivative is 1, this one's is 1.
That's 2.
Yeah, so it's not like dy dx equals 1 times 1. So it's wrong. It's wrong to do it individually, differentiate individually. You can't do it that way. So we need to figure out, okay, well then what is the rule? You don't have to write that bit down, that's okay. It's just me kind of talking. So let's figure out what the rule is. We want to figure out what is the rule if we have fx times gx, what's the derivative? And I'm telling you now, it's not f derivative, g derivative. It's not that. Let's figure out what it is. So, we'll do dy dx, delta y, delta x. That's f x plus h. Have you seen this rule? Gx plus h. You did this with John? Fx.
No.
Ah, you did. You did.
What's plus
But it doesn't.
I'm not sure
It's
which
the same?
one.
Oh, look, it's right there.
What?
You forgot this?
Oh, yeah. We do this, but we cancel the edge because we just
Yeah,
edge is 0.
I'll cancel it in a minute. Okay, so this is fx plus h, gx plus h. Okay, and then there's a little trick here. let me just think, minus fx gx plus h. Plus fx gx plus h. Okay, and then minus fx gx. So what I've done is I've added this piece in the middle which cancels. Okay, now if you look at the first two, can you see that gx plus h is invoked?
Yes. If not one.
It's common.
Yeah.
And if you look at the next two, fx,
And
fx is in common. Yeah, so I'll use a different colour, I'll use grey. fx and fx is there.
You are not common over there.
Yeah, the fx is the common one, and the gx plus h is the common one here. So what I'll do now is I'll take out the gx plus h, and I'll just put it on the back here. And here I'll take out in the front fx, and then I'll have here gx plus h minus gx. Okay, and this is all over h, isn't it? So this is over h, and this is over h. Now, what happens, Ben, because you just said it a moment ago, when the h goes to 0? What will this be? No.
Fx minus fx
Over h.
over h.
Yeah, and h is 0.
But, h, it doesn't be 0.
Mm-hmm.
It can be,
Mm-mm.
but
Mm-mm.
you know,
Mm-mm.
sorry to say.
It becomes this.
Oh.
F derivative.
Oh.
Because this is the first principal definition. When you have x plus h, fx plus h minus fx over h, and you make h go to 0, then this becomes the derivative. Did you write the formula down? No. You didn't write the formula down. Ben, this is the formula for f derivative.
Okay.
And this becomes g, and this becomes f, and this one becomes g derivative.
Oh.
So the answer is, the rule is, if y equals fg, then y derivative equals f derivative g plus fg derivative. That is called the product rule. Oh goodness.
We're not going to apply all the h's.
So again, to the x terms. Where is your notebook, Ben?
You pick up?
No.
Yeah, well, you should have a notebook. Where's your notebook?
I'm math no only.
Oh, Ben, no. Oh, Ben, I don't like this. You use your workbook as your notebook.
But I have to be speaking.
What?
Actually, I have notebook, math notebook.
Oh.
But
And Joan wasn't angry with you?
no.
Are you sure? Joan was okay with this? She didn't mind? Did she not say to you, Ben, buy a notebook?
Maybe she don't know.
Oh, okay. Oh well, I'll talk to her. Okay. No, I won't like this, Ben. I want a maths notebook.
I have one.
Okay. Khalifa, do you mind giving him some paper for today?
Oh, I have paper.
You have paper? Okay, I want you to write this down. I'm a very mean maths teacher, not like Joan. She was probably a very nice maths teacher. What do you think, Ben?
It's okay.
Okay.
You're very kind.
Oh yes, I'm kind, yes, okay.
So I understood what I want to ask question there.
Yeah.
The third line.
The top line, yeah.
The third line.
Oh, the third line, sorry, this line.
Yes.
Yeah.
Fx plus h.
Yeah.
Gx plus
Yeah.
h. Then minus
Yeah.
fx.
Yeah.
Why isn't there plus h there? Or the g has plus h.
Yeah, yeah. The reason for this is, I understand why doesn't this have the plus h.
Yes.
So the reason is, this is a piece that I add in. And the reason I add this in is because I want to make this on the next line. Now you might say, well, why didn't I have x plus h? Well, the problem is, if I had x plus h here, then on this line, instead of having fx, I would have fx plus h.
Yes. Is it okay?
No, because the formula for the derivative must be x plus h and x.
Okay, but the g must have plus h.
The g, because these two must be the same,
Okay.
so you can take it out as a common factor.
Okay.
Yeah. Okay, okay. Happy?
Oh,
Yeah. Okay. Now that we have our rule, let's look at some examples. So let's go back to our very first example, y equals x squared sine x. So if we want to calculate the derivative, first we differentiate x squared. What's the derivative of x squared?
2x
2x.
sine
Sine x. Then you keep the x squared the same, and then differentiate sine x. What do you get?
cos.
What's wrong with you, Ben? What are you
No,
looking
no,
for?
no, no.
Oh, your table.
Because first principle and something will indefine something.
Yeah.
You will change to this is first principle,
Yeah.
and we usually opposite it because 2x.
Integrate.
Yeah.
You mean this?
Yeah.
Yeah. Oh, Ben, you need to learn your words. This is integrate.
Okay.
Yeah, opposite. Yes. There you go. Ah. What did you get in your EAP exam?
I don't know.
Okay.
Wait, not good.
I think between the three of you, because your EAP will be good, of course, between you, Summer, and Gao, I think Gao is doing the best in the EAP. Yeah. But she has an Irish uncle. Doesn't she? Her uncle
Oh yeah,
is Irish.
maybe.
I think so. Isn't that what she said?
Yeah,
Be-
his car, he drives.
Yeah, drives the taxi. Yeah. Okay, let's have a look at another example. Can I scroll down? Yeah. Right, let's try this one. Y equals x log x. Okay. Y derivative. Ben, derivative of x, what is it?
1.
Okay. Khalifa, do you remember the derivative of log x? If you don't remember, do you have your notes from Joan?
No.
There's a table. Yeah, okay, it's a new notebook. Ben, do you remember the derivative of log x?
1 per
Oh, don't say per, that's physics. 1
over
over
x.
x plus, oh no, sorry, sorry. I'm very tired. 1 log x plus x times 1 over x. Okay, so the answer is log x plus
1.
1. Okay. Let's do a harder one now. Can I scroll down, Khalifa? Yeah. So, y equals fgh. What do you think the rule might be for 3 of them?
I don't know.
I think you might. Look.
We apply the rule of the f and g, then the h.
Yeah, so what do you think the answer might be?
F x plus h. G.
Oh, you could work it out.
Yeah.
Yeah, but I guess what I'm trying to say is without doing all that work, could you guess what the answer might be?
F x plus h minus.
No, the final line. See the rule?
Oh, here?
No, after that.
Rule.
Yeah. So that's for f and g.
Okay.
See, here it is here.
Yes.
My question is, imagine instead it was FGH.
Yeah.
Looking at what the rule is for FG, could we guess at what the rule might be for FGH?
Right derivative.
Yeah.
F
Derivative
derivative h
GH.
gh.
That's what I'm going to say. Okay.
Plus f g then h derivative.
Nice try. G derivative H.
Okay. Is this
Plus
plus f g then h derivative.
it's like this. So can you see what it's?
That's second term.
That's it. Can you see the pattern? So the derivative is first on the F, then it's on the G, and then it's on the H. So it moves across. Yes? Is that okay, man? Yeah? So let's try an example. X, EX, sine X. Let's get the derivative here. Okay, Ben can give me the first piece, and then Khalifa, maybe we could try for the second piece. So Ben, what's the derivative of
ex
F?
sine x.
Yeah, it's going to be 1, yeah, EX sine X. Khalifa, what's the derivative of EX, the G part? Do you know the derivative of EX? I don't think we've done it today. No. Ben, do you know the derivative of
The
EX?
same x, ex.
Yeah, EX's derivative is EX. And the derivative of sine X?
X, ex, cosine x.
X, EX, cos X. That's the answer for this one. Yeah? Continue? Right. Now, I'm going to give you both a hard one. I'll let you try it for a minute, then I'll give you the answer. Can I scroll down? Okay. Okay. Find the turning point to y equals ex cos x, where x is between 0 and we'll say pi. So First question is, do you remember what this word means? Turning point. Do you remember it, Ben?
First principle.
No.
Second.
First derivative. What?
It is derivative. Okay. Okay. Slope. No.
Turning point. Here, next page. Like, here, turning point. Minimum,
Yeah. I know.
maximum. They're turning points.
I know. So, I means we use first principle to find a
First derivative, not first principle.
second derivative, but I.
No, first derivative.
Okay.
It's clear, yeah?
The one you just solved
Yeah.
previously, x is equals to what?
Mhm.
The x sin x. No.
Yeah, so they stay the same.
Yeah.
Then the middle
Second
piece,
one, the middle piece, x. What?
x is still x.
Yes. Okay. What is
EX becomes EX.
Yes, ex. But x can become one as here.
No, in the first one, only the x changes.
Okay. If it was s squared, then
It'd be
one-
2x.
Okay, 2x.
Yeah,
Okay.
yeah. So, wait, what are you trying to solve? So you're trying to solve,
Huh?
what are you trying to solve? You are trying to solve, you see, okay, you wrote it down, but what is that? What is that? It's called the first derivative.
Okay, first derivative.
Equals 0. You want to solve this?
Yeah. Okay.
Yeah, okay. You need to learn these words. Ben, learn these words. Derivative.
Derivative.
Thank you. Okay, now I'll give you a minute. Try and solve it.
Okay.
Good.
Okay, so yeah,
You have to find the derivative. In radians.
Pi over 2.
No. No. Not 90. Ben.
What?
Pi over 4.
What? Pi over is
45.
45. Still? Here. Oh. Yeah.
Yeah. Yeah. I think your maths teacher you had was very bad. You don't remember this. Bad maths teacher.
Oh. I know. I know.
You know it. I know you know
I'm
it.
confused. Is you know the tangent theta
Hmm?
tangent.
Hmm?
It has ten. How to say? It's a periodic.
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 Yeah, correct. Like this, yeah. Oh, sorry. Like this.
Yeah, I think it's the turning is what?
Yeah. 45.
It's 45.
Yeah.
But I think the period is only pi, so half.
No.
Okay.
It's okay. It's okay.
But I know the.
You know, the triangle, yeah. Okay, so look. Ben, what did you get for dy dx here? Ex
cosine x.
Yeah, minus ex
sine x.
And that should
Equal 0.
and that should equal 0. So you can take ex out, and that should equal 0. Yeah? So that means cos x minus sine x should equal 0. So that means cos x should equal sine x, which means tan x should equal 1, which means x should equal pi over 4. Then you can put that back in here, and you get y equals root 2 over 2 e pi over 4. Well, okay. I don't know, Khalifa, does your calculator give you decimal answers only, or does it give you...
It does.
Yeah, so if you were to type... Now make sure it's in radian mode. Oh yeah, Ben, I forgot to say that to you as well. You must use radian mode on the calculator. You must, for these problems. Because the rule that says cos x derivative is minus sine x, and sine x derivative is cos x, that is only true if it's radians, not degrees.
So, tangent theta cannot be 90 degrees.
Correct. So it can't be 90. So, yeah. So I should have perhaps said, sorry, pi over 2 here. Okay, did you write this down?
Yes.
Yeah? Write this down. So what I'll do, I don't think there's much more to it for the first lesson for this. So how are we doing? Yeah, okay, good. Well, it's easy to teach only 2 students. It's not as much much time. So what I'll let you do is I want you to practice some of these. Okay?
Practice.
Yeah. So the first ones are, you just have your 2 functions. You see here, look like sine, cos, the usual stuff here, okay?
1, 2.
No, okay, no, wait, well, let me tell you which ones.
1, 2,
You can change it.
this one.
No, okay. Okay, no, you don't need to. Okay. Give me your pen, let me mark off some for you to do now. Yeah, now 1, 2, 3. Yeah, nice. Oh yeah, I forgot to do this example. We'll just say 2 of those.
Oh,
You know what? You know what the idea is?
I wrong.
What?
Math exam.
Ah,
I
yeah,
the rule.
yeah.
I just derived to roll this.
You made a mistake?
Yeah, I think.
That's okay. I forgive you. Now, look at this one. Before you start, there's one more example I want to do. Sine squared x, what's the derivative? Well, the trick here is to change this into sine x, sine x. So then the derivative would be cos x, sine x, plus sine x, cos x. So the answer is cos sine plus cos sine is 2 cos sine. Or sine cos, whatever. There's 2 of them. So that's the answer. So the trick, this is the trick here. is to change the square into sine. Yeah? Wait, what?
I think it is sine 2 theta equals 2 sine
Correct.
theta cosine theta.
Correct. We'll do.
But why is the same idea? No, the same answer.
Huh?
You know, this.
This is not.
I know it's
Okay.
other.
Why is it the same?
Yeah.
Why not? So you're saying this equals sine 2x? Yeah? Yeah, so it means sine squared x becomes sine 2x.
Amazing. Okay, fine.
I'm happy you think it's amazing. I'm happy. Okay, so can you try these for a few minutes and then we'll go to the next lesson. I'll close. Can I close this?